In this video, we're going to be talking about solving equations with variables on both sides. So we're going to solve and check. I'm going to check the first one. I'll leave the rest of the checking to you. First thing we need to do is we need to get all of the variables on the same side. So 3b is on the right side alone in this equation, so let's subtract 4b from each side to move it over to the other side. So the 4b's cancel, and we have 2 equals negative 1b. We want to get b alone, so we're going to divide everything by negative 1, and we end up with b equals negative 2. Check it. So we have 4b plus 2 equals 3b. We want to make sure the negative 2 works there, so we're going to have 4 times negative 2 plus 2. We want to know, does that equal 3 times negative 2? So I'll put a little question mark above the equal sign. 4 times negative 2 is negative 8. Negative 8 plus 2 is negative 6. On the other side, 3 times negative 2 indeed gives us negative 6, so that checks. So let's move to the next one over here. 0.5 plus 0.3y equals 0.7y minus 0.3. We want to get all the y's onto the same side, so it's up to you which one you want to move. It really doesn't matter. I'm going to move the 0.3y, which I will do by subtracting it from each side. 0.3y's cancel, so I have 0.5 equals 0.4y minus 0.3. Now I need to get y alone, so I'm going to add 0.3 to each side. They cancel, so I have 0.8 equals 0.4y. We want to get y alone, so we're going to have to divide each side by 0.4. The 0.4's will cancel, and we have y equals 2. I'm going to have you check that. Next one, we want to get all the n's onto one side. 7n minus 2 equals 5n plus 6. Decide which one you're going to move. I'm going to subtract 5n from each side. You could always move the 7n if you want. 5n's cancel. So we have 2n minus 2 equals 6. We want to get n by itself, so we're going to add 2 to each side. 2's cancel, and we have 2n equals 8. We want to get n alone, so we're going to divide each side by 2, and we have n equals 4. This next problem has parentheses in it, so we want to get rid of the parentheses first, and we do that by using the distributive property. So when we multiply through the parentheses by a half, we have 1/2 b plus 3. 1/2 times 6 equals 3. And then we have 3/2 b minus 1 on the right-hand side. So now we want all the b's on the same side. Now we're actually going to start the solving. So I'm going to subtract 1/2 b from each side. The 1/2 b's cancel, and we have 3 equals, oh, I don't know why I crossed those out. I'm sorry. 3/2 b minus 1/2 b. Don't cross those out. I'll see if I can erase that a little bit. Okay. That looks a little bit better. 3/2 b minus 1/2 b just gives you 2/2 b, or just b. So we have b minus 1. And now we want to get b alone, so we're just going to add 1 to each side. And we end up with b equals 4. Okay, so next, we have 3x plus 15 minus 9 equals 2 times parentheses x plus 2. Get rid of those parentheses, so distribute. So we have 2x plus 4. Notice on the left-hand side of the equation, I'll draw my line down. You know I don't draw my lines very straight. We've got two like terms. We have the constants 15 minus 9, so let's combine those so we get 6. So we have 3x plus 6. We want to get all the x's on the same side. So let's subtract 2x from each side. The 2x's cancel on the right, so I'm left with 4. On the left-hand side, 3x minus 2x just gives me 1x, or x. So I have x plus 6 equals 4. We want to get x alone, so subtract 6 from each side, and x is negative 2. Let's move on to this next problem, which I'm actually going to have you try on your own, see how you do with that. Let's go to the next page. An identity. This is an equation that is always true and has infinitely many solutions. For example, 2 plus 1 is equal to 2 plus 1. That's always true. 5 plus x is equal to 5 plus x. Any number that you put in place of x will make that equation true. You can say 5 plus 2 equals 5 plus 2. That's always true if you want to choose x equals 2. If you choose x equals 10, it doesn't matter. 5 plus 10 is always equal to 5 plus 10. There are infinitely many numbers that you could put in place of x. Now, a contradiction is what we call a false equation. It has no solutions. All right, something that's false. 1 equals 1 plus 2. That is not true. I'm going to put a slash through it. That's not true. X equals x plus 3. There is no solution where you could have a number equal to itself plus 3. That can't work. It has no solution. 1 equals 3. That's completely false. Okay, so we're going to see some examples of identities and contradictions here. Let's solve this equation. Notice on each side there are some like terms we can combine. On the left we can combine the constants 10 and 1, so we have 11 minus 5x. On the right hand side we can combine 7x minus 12x, which gives us negative 5x plus 11. Alright, we want to get all the x's onto the same side. So let's add 5x to each side. The 5x's cancel on the left and the right. I should have done that in reverse. And we end up with 11 equals 11. Is that... So because we have 11 equal to 11, that is a true statement. And there are infinitely many solutions. So let's continue. 12x minus 3 plus x equals 5x minus 4 plus 8x. Let's combine our like terms. We have 12x plus x, which is 13x, minus 3. On the right-hand side, we have 5x plus 8x, which is 13x minus 4. We want to get all the x's on the same side, so we're going to subtract 13x from each side. And we end up with negative 3 equals negative 4. That is definitely not true. That's a contradiction. And as a result, it's no solution. Because the previous problem was a true statement with infinitely many solutions, we do want to add that that problem up above it is called an identity. Let's try this next one. We want to get our like terms combined. So we have on the left-hand side 4y minus y. So we have 3y plus 7 equals 10 plus 3y. We want to get all the y's on the same side, so we'll subtract 3y from each side. And we end up with 7 equals 10, which is definitely not true. That is a contradiction. And that means there are no solutions. The last problem, John and Sarah are planting tulip bulbs. John has planted 60 bulbs and is planting at a rate of 44 bulbs per hour. Sarah has planted 96 bulbs and is planting at a rate of 32 bulbs per hour. In how many hours will John and Sarah have planted the same number of bulbs? How many bulbs will that be? Well, let's look at what John and Sarah are both doing. Well, John has planted 60 bulbs, and he's planting at a rate of 44 bulbs per hour. So let's say that X is the number of hours. Sarah has planted 96 bulbs, and she's planting at a rate of 32 bulbs per hour, so 96 plus 32x. We want to know when they will have planted the same number of bulbs. We want to know when those two expressions are equal to each other, making an equation. So we want to get all the x's on the same side. So we're going to subtract 32x from each side. The x's will cancel, and we have 60 plus 12x equals 96. We want to subtract 60 from each side, and we're left with 12x equals 36. Divide each side by 12, and we get that x equals 3. So, when they've both been planting 3 hours, they will have planted the same number of bulbs. Now, how many bulbs will that be? What we're going to do is plug that 3 in place of the expression for John, and it should be the same amount for Sarah. So let's see. So we have 60 plus 44 times 3. Well, 44 times 3 gives you 132, plus 60 gives you 192 bulbs. Now Sarah should be the same amount. Let's see. The expression that she had for her number of bulbs was 96 plus 32x. So let's plug that in. So we have 96 plus 32 times 3. So that's 96 plus 96, which again gives us 192. We got John's by just plugging that into the expression we had for him, which was 60 plus 44x. And we got the number of bulbs for Sarah by plugging x equals 3 into her expression, 96 plus 32x. And of course they did end up the same. So that's our last problem, and thank you for joining me.